In this video, we will understand how two charges Q1 and Q2 interact with each other when they are placed at a distance r from each other. The law of interaction was given by Coulomb and is known as Coulomb's law. According to Coulomb, the force between two charges is proportional to the product of magnitude of the charges and inversely proportional to the square of distance between them. Combining both equations, we get F is proportional to Q1 Q2 over r square. We can remove the proportionality sign by adding a constant of proportionality k, which is known as the electrostatic constant. The value of this constant is 9 into 10 raised to power 9 Newton meter square Coulomb square inverse. Further, this electrostatic constant is also equal to 1 over 4 pi epsilon naught, where epsilon naught is the absolute permittivity of free space. Therefore, we finally have F equals 1 over 4 pi epsilon naught Q1 Q2 over r square as the force of interaction between the two charges. Till now, we haven't associated any direction with this force, but we know the force is a vector quantity and we must associate some direction with it. Therefore, we will now see vector form of the Coulomb law. For this, we consider Q1 and Q2 placed in Cartesian plane with r1 as the position vector of Q1 and r2 as the position vector of Q2. The displacement vector will be r vector, which represents the distance of separation between the two charges. For the first case, we will be examining the force on charge Q2 due to Q1. F21 will therefore be equal to k Q1 Q2 over r square times the unit vector r cap. We know unit vector is vector divided by its magnitude, therefore we have F21 equals k Q1 Q2 over r square times r vector over r magnitude. We can write the displacement vector r vector in terms of position vectors r1 and r2 by using triangle law of vector addition. From the triangle formed, we can easily recognize that r2 will be the resultant, therefore we have r2 equals r1 plus r vector. Therefore, r vector can be written as r2 minus r1 vector. Therefore, we ultimately get F21 equals k Q1 Q2 over r2 minus r1 mod whole cube times r2 vector minus r1 vector. We will now find the force on charge Q1 due to charge Q2. Therefore, the displacement vector will now point towards charge Q1. Proceeding in the same fashion, we get F12 equals k Q1 Q2 over r square times r unit cap. Again, unit vector can be written as r vector divided by its magnitude. The difference here will be that r vector will be now equals to r1 minus r2 vector. Therefore, in the end, we have F12 equals k Q1 Q2 over r1 minus r2 mod cube times r1 vector minus r2 vector. Analyzing both these equations, we can easily recognize that F12 equals minus F21. Therefore, we can conclude that Coulomb's law is in accordance with Newton's third law of motion. And these two equations represent Coulomb's law in vector form. So this was it for this video. I will see you in the next one. Till then, stay tuned. Thanks for watching.